Today we are going to model, get the, whatever they call it, where you walk down the catwalk or whatever. But no, we're going to model the quadratics. All right, so we'll review what we've already done as far as modeling quadratic, and then we'll do the new thing. So suppose I tell you that the vertex of a certain parabola is 2, 5, and that there's a point on this parabola that is the point, say, 4, 12. No, we'll do 4, negative 12, just because to do a negative. I have two pieces of information, but having this vertex is really powerful because then I can go to my vertex form and use y equals a times x minus h squared. Don't forget that squared, because if you forget it, then it's wrong. Plus k. And I have my vertex. So what we did the other day is we would put in our h and k. And then, off to the side somewhere, we would use the point to calculate a. So we put in our x and our y. And then we have negative 12 equals, and then we have 4 minus 2, which is 2. And then we'd square that.
Is this a combination of what we're doing on Friday?
I'm reviewing what we did Friday. And then we subtract the 5. And then we divide by 4, and we get negative 17/4. That's a terrible stretch factor. You could do it. That's why I've said, have your calculator handy when you're graphing these. And you can always graph with a table of values. And you basically put in the function on your calculator, get a table. But we just take that a and put it back in. That's what we were doing on Friday or before the last section in order to get a model. But today, we're going to say, well, what if I don't know the vertex, or I don't know for certain if one of the points I have is a vertex? So I'm going to be given 3 points. Now, it has to be 3 points. Unless I have a vertex, it has to be 3 points. I mean, one of these might be a vertex, they might not, I just don't know. But I know that these 3 points are on my parabola. When this happens, I cannot use vertex form. When this happens, I must use standard form. Vertex form is way easier because we get our vertex and we can put in a point and figure out our stretch factor. But here, I just don't know anything. I don't know the vertex. I just have these 3 points. So our standard form is y equals ax squared plus bx plus c. And in order to do this, I am going to have to find a, b, and c. From all of these are x's and y's. So if I have 3 unknowns, I need 3 equations. And now you should get really worried. Uh-oh. This is what we did before last chapter, solving a system. I'm going to put each of these in one at a time to get a system. Y is 0. A is something I don't know. X squared. Well, 1 squared is 1, right? So I have a 1 here. Plus bx. I'm just using this first point. X is 1, so plus b plus c. That's my first equation. These are all 1s. Next equation, y is negative 3. And now x is 2. But notice it's 2 squared. So that's 4a. The next one is b times 2, so 2b. And then plus c, 1c. And the last one is negative 10. And then I have x is 3, so that's 3 squared, so that's 9a. Plus 3b plus c. I now have a system. I'll solve that system on the next slide. So I'll copy that. Copy. Paste. Okay. And we'll go over again how I got that system. But let's just review how to solve it. Generally, for all of these, the easiest to eliminate is C. So I'm just going to hold this first equation as my constant equation. And I'm going to flip it around because I'm just used to having the other thing on the other side. I'll multiply this second equation by negative 1 so that I can eliminate C. I'll set up the next one as well. I'll multiply that by negative 1 so that I'll be able to eliminate C. And usually it is going to be C that's the easiest to get rid of. So I get negative 3a minus b equals 3. And over here I get negative 8a minus 2b equals 10. The C is eliminate. And then remember I take these two things and eliminate. I'll probably eliminate b. So I'll multiply the second one by negative 2. And this is really just an application of what we did with our systems last chapter. So I get A is negative 2. And then remember, we back substitute that in. So I'll get negative 3 times negative 2. All right, so I have my B. And then I'll back substitute all of those. I'll just put it into this first one. So 0 equals negative 2 plus 3 plus C. So I get 1. And C is negative 1.
You include the fraction, John?
First factor that. Always factor first. Aye.
But doesn't you have to put zeros in one? Do we put zeros in one division? Or is it only just negative 5?
No, you can multiply that by negative 5 to get that. So your remainder is something else.
So if I go on and put 0 x?
Yeah.
So you have to do 0. Or you have to put 0 for the
Yeah, it'll just be for consistency to always fill in the missing things. Yeah.
Now what?
Hold on a second. All right, so now we have our ABC. Remember, our standard form is ax squared plus bx plus c. I've just found a, b, and c. So our standard form is negative 2x squared plus 3x minus 1. Okay. No. That's not how they factor. Always factor out the common thing first. You factor out x. And then you multiply both sides by x and x plus 4. All right, let's do another example. Let's say I have 1, negative 2, 2, negative 4, and 3, negative 4, and I want to find the equation of the parabola. Now notice on that last one I didn't bother changing it to vertex form. I could, and we'll review how to do that in a moment. But what I need to do and what you need to do in order, because most of this is review, it's just setting up the form, the system is what's new. The rest of it is stuff that we've done before. So since I don't have a vertex or I just have 3 points, I need to use my standard form. These are x's and y's, each of them. So I'm basically substituting each of these in to generate my system. So y is -2, and then x is 1. And then I simplify that. So this generates this equation. And then I take this next point, y is -4. So I replace y with -4. And then I have a x squared so I'm going to get, this simplifies down to 4a plus 2b plus c. So this generates this equation. And finally, ooh, this was nice. They gave me the same y value, so I have -4. So that really makes me think, well, this isn't the vertex. The vertex would be between these two. It's probably 2.5, just a guess, but I don't know. So x is 3, so that's going to be 3 squared plus b times 3. See, I'm just substituting x and y in. So this equation simplifies down to -4 equals 9a plus 3b plus c. And again, the easiest to eliminate is going to be c. And just to say that we did, let's go ahead and solve this system. So I'm going to just write the system that I'm solving over here. And again, you can use your calculator to check your work, make sure it's right. If you've done it right, all 3 of these points should actually be on the parabola. So I'll grab this just to get some space. Since I'm going to eliminate c and I don't want to compound my problems, I'm going to multiply the first equation by -1. And usually it'll be c that you eliminate. Then I'll pair that first one up with the other 2. Just like we did the last chapter. And then I combine them. Looks like I'm going to eliminate b again. So I'll multiply that first one by -2. Boy, this looks like the same one I just did. Looks like it came out like pretty much the same. That should be a positive 4. That should be a -b. And then I combine those. What in the world? Why do I have a 4 there? That should be a 2. Alright, so the b's cancel is the point I'm driving at there. And a is 1. So now I take that a and I'll put it back into here. So I have 3 plus b equals -2. So b equals -5. And then I take both of those, I'll put it in that first equation. So 1 plus -5 plus c equals -2. -4 plus c equals -2. And c equals 2. Alright, that's a little bit different. So my final answer is y. See, this is my standard form. And I just went through finding a, b, and c. So I just put those in. A is 1, so that's x squared. B is -5. And c is 2. And just to say that we reviewed it as far as finding the vertex, from standard form. Let's review that just to make sure. Because this is standard form, but if I wanted to graph this, I would want it in vertex form, wouldn't I? So let's actually use this as an example. This is actually probably a really hard one as far as getting the vertex form. What was it, +2? Let's get to vertex form. So h is negative b over 2a. So I get 5 over 2 times 1. So 5 halves. And k is going to be, put that in for x. So I get 5 halves squared minus 5 times 5 halves plus 2. So k is 25 fourths minus 25 halves plus 2. Ugh. Get a common denominator. So it'll be times 2 to get a common denominator. Get a common denominator. So that's a 1. So times 4. And then I get negative 25 plus 8. So negative 17. So k is negative 17 fourths. Negative 17 fourths. So I have my h, I have my k, and my a is 1. So my vertex form is y equals a x minus h squared plus k. I know my h and k and my a. A is 1. X minus 5 halves minus 17 fourths.
So last slide.
12.
The previous slide?
The answer for that.
So you put in A, and it's, okay, it's not a negative 1, right? A is not a negative 1.
It's a positive one. Any questions on these? Well, first of all, any questions on what we did as far as this, getting this system? Okay, any questions on getting the standard form to vertex form?
Neither right now.
And then finally, any questions on from a vertex and a point getting vertex form? I'll do one more of any one of those three. You just need to let me know if you need to see it. I'm hearing that we're good. We're happy.
Black eyes or black?
This is a cane happy.
You have one
Shout
eyebrow?
it.
Yes.
And happy to shout.
Like,
All right, I guess we're done.